Hello. So today is all about 3D. So if you know me and you know my work, you know I'm passionate about using 3D and Webflow, but using real 3D, interactive 3D with ThreeJS and Webflow together was just a dream for me for a long time, but not anymore. I decided to finally get my hands dirty and learn how I could use ThreeJS, React 3 Fiber, and a few other things to create a process where I can just build something in Blender, which is my 3D software of choice, and move into Webflow. So this tutorial today is all about that. So let's get to it. So before we start, let me just give you a few observations about this video. So this video is not meant to be a comprehensive, long tutorial or masterclass about how to build stuff in Blender, or how ThreeJS works, or how JavaScript works. There's a few things that I'm assuming you know up front before starting this tutorial, because this tutorial is more about the whole process that I created for myself. Like, how can I just build most of it on Blender and then just turn into something that I can embed into Webflow. So it's more about the process, walking you through the process, rather than just like a beginner-friendly tutorial about coding. So it's not about coding, it's about the process, okay? So I'm assuming you have some basic to intermediate knowledge about how to use JavaScript in general, how JavaScript works, how ES6 works, how modules in JavaScript works. Also, I'm assuming you have some basic knowledge on how to do 3D, how 3D works, and how Blender works. So you can use anything. You can use Spline, you can use any other 3D software, but the outcome will always be the same, and it's a specific file format. We're gonna talk about that later, but I'm assuming you have some basic knowledge about how 3D works and how to create a scene on 3D with materials, lighting, etc. Because I'm not gonna show how to do that. I'm gonna show what I did, but translating this process to your specific use case, it's up to you, okay? And also, I'm assuming you have some very basic knowledge about React. To be honest, I don't know React as well. I'm not a huge fan of how React works, but I must admit that React 3 Fiber, which is a library for React, makes your life a lot easier when you have to code something in ThreeJS, because it allows you to create like a modular, a really close experience to writing HTML tags with React 3 Fiber. So you're gonna see what I'm talking about later on this video. That's it. So let's take a look at this. So this is the example that I created for not only this tutorial, but it was the task case for myself to learn how to do all of this. So it was extremely inspired by Work Louder products. So he has some custom keyboard. It's beautiful stuff. Make sure to check it out. And I was specifically inspired by it's a keyboard, it's a micro keyboard with just a few custom keycaps. It's fantastic. So I just created like a fake product, which is a limited edition for Webflow. So it's a small keyboard specifically for Webflow shortcuts, Flowboard. And what you see here is basically a Webflow landing page. But you do see that we have some 3D here, and I can click on it, so it's interactive. And I start scrolling, and then we see that the 3D is like rotating and moving around. I can still click here, then it moves again. I can click on the dial, then again, and then it goes to the bottom. So you see that all of these text effects, these are all HTML stuff. It's all built inside Webflow. It's using some GSAP to animate the text. And then we have one element inside Webflow that holds the whole ThreeJS canvas. So all the code we're going to see today will generate something that will be included inside this one specific element inside Webflow. So that's how I'm mixing things together. Okay, so how do we add WebGL to Webflow? So my process for this, and like, there's multiple ways of doing this. You don't need to build your scene in Blender. It's my choice. You can just build things from scratch in ThreeJS with React 3 Fiber. But I'm pretty comfortable with Blender, and I think I'm faster doing that there than trying to do the same thing with ThreeJS directly. So my process starts with Blender. So we're going to create a scene on Blender. So everything related to the 3D scene, the models, the materials, and some of the complex animations, all that will be done inside Blender. That we're going to take that file, we're going to import into a tool that will create a React component for us on top of the file that came from Blender. After that, we're going to import a file and that specific React component into our one tablet on CodeSandbox. And CodeSandbox, it's a browser-based coding environment. It's fast, it's flexible, you can do pretty much anything there. There's a live preview, and you can share it. If you need help from someone else, you can just share your sandbox. So it's very useful. And the version of CodeSandbox we're going to use is the cloud version that allows you to have a complete code environment that includes Node.js. It's like you're developing locally and you have Node.js. If you don't know what Node.js is, it's like using JavaScript to run scripts on your local computer. And those scripts can do lots of stuff. For example, you can take multiple files, multiple JavaScript files, and bundle all of them into one specific file, which is exactly what I'm going to do. I'm going to decompose our code on CodeSandbox into multiple files. I'm going to mix them together, and I'm going to run a script on the cloud version that will generate a static JavaScript file for us that we can just take that URL and embed into Webflow. Yes, the last piece of the puzzle is Webflow itself. So I'm going to see this whole structure for this landing page that I showed you, and that structure, it's all done in Webflow. So I'm going to show you all the moving pieces and the interactions that I had there, and how I created the main element that holds all the 3D stuff. Okay, so quick recap. Step 1, we're going to build our scene in Blender. Step 2, we're going to use a tool, that's the name of the tool, GLTF JSX. We're going to use that to convert our file into something that we can import and code easily. Step 3, we're going to use CodeSandbox to prepare all the interactions and everything, and generate a file that we can use in Webflow. And then finally, we're going to jump into Webflow and make magic happen. All right, so let's get into step 1, Blender. So on Blender, we're going to, like I said, build the whole scene, the models, shading, textures, lights, everything. We'll also create animations, for example, scroll-based animations, the way you saw on the demo I showed you. It's all done in Webflow. There's no ThreeJS code doing those things. The only thing that happens on the code is running the whole animation as you scroll. Like, run the progress of the animation as you scroll, right? And then after that, I'll show you how to export that into a specific file called GLTF, which is the file format that we pretty much use everywhere on ThreeJS when we are importing models from somewhere else. Okay, this is my Blender scene. As you can see, here is our Flowboard. Okay, and I model all of this in Webflow, so there's no secret here. It's basic stuff, like some basic geometries based from planes and squares. So you can see all the geometry right here. Right, I have a few modifiers here to make things a little bit smoother, like subdivision modifier, mirror modifiers, right? You can add like bevel modifiers, whatever you want. So I basically created all the pieces inside Webflow. Okay, you can see here on the navigator that we have multiple collections. We have the keys, so each one of these keys are right here, and they're all properly named. This is very important. So make sure you're naming all your geometries or meshes on Blender, because you're going to use those names as reference later. So I have the keys group, I have the base. So this is our base objects. So this is the metal part. I have the let me just open here. So you can see everything is connected. They're children of the base neon mesh. Okay, so we have the steel base, we have the bottom metal piece, we have the rubber piece right here, and what else do we need here? What else do we have? We have the screw, and that's it. So these are all the shapes, the meshes that we have here. Then we have our camera inside our scene collection. So we have the camera, and we have two area lights, one on the kind of the top and then one on the side. Okay, so basic stuff. If you know Blender, you know how to do all this. Compose your scene, build your the parts of your scene, adding a camera, adding the lights. That's basic Blender stuff. Okay, then we go into the shading view, and you can see here. By the way, I'm using Eve as my render engine here because it's a lot more closer to what you're going to have on ThreeJS compared to cycles. So it's better to use Eve to visualize your scene, right? So we can see here that the lights are working as expected, and I have all of these meshes with some custom materials. So I wrapped all of the keycaps and this panel so I can add it later some textures. So this is how I created here. We have multiple materials for all of those things, so we can pretty much create all the materials on Blender, like most of them, right? You can see here that we don't have the neon effect on this. This is the only thing that we will create later on ThreeJS, because there's a few specific things that won't be properly translated from Blender to ThreeJS, okay? But the majority of it is just materials created directly in Blender. So that's the beauty of using Blender. If you're familiar with it and you want to create something on ThreeJS, you can just use your standard process to create your scenes, and then this will work great on ThreeJS later. So all of these are custom textures. Actually, I have just one texture, if I'm not mistaken, and then just translating the position of the texture using the mapping node here. So that's how I created the materials and configure the lights using the shading part. And then the last piece of this puzzle is the animations, scroll-based animations that we've seen before. So here on the animations view, so we have here our scene, and there's only two parts here on Blender that I included animations. I created the animations directly on Blender because these are the only moving pieces there. They're not directly interactive, and then that we can just create on Blender itself. One is the camera. So if I click here, you see that I have 150 frames, right? Because I made some calculations, so it's like 100% of the landing page will have the scene fixed on the screen, right, as a background. And I have five sections. All the 5 sections has 100 VH, which means that they are equally divided. So it's like the whole body height divided by 5. So it's all equally taking the same screen space vertical. So if my scene has 150 frames, then my animation will change the position of the camera and the keyboard every 30 frames, right? Because 150 divided by 5, it's 30 frames. Okay, so you can see here that if I start moving on my timeline, the keyboard is moving and the camera is moving at the same time. Let's just focus on the camera on this side right here. That's my camera. And you can see that when I start moving, I'm just select the camera again. I have keyframe here, transitioning into this one. Then we stay on the same position for a while, and then we transition again. We rotate the keyboard again, and we move the camera again. The camera is moving right here. You can see the camera moving around. Okay, then we do the same when we come closer to the third part. Rotate it looks like this. Then we rotate the camera and the keyboard again. That's when we arrive in the footer on the landing page. So basically it's just the camera, and if I select the base neon, which is the body of the keyboard, it also has these keyframes. And everything else moves because everything it's children of this. So this is the main parent, and everything from the keyboard itself is connected to this base here, the body of the keyboard. So that's why we can just move and transform and add animations to just two elements, the camera and the keyboard. So that's how I build the animations here. There's one very important tip here, something to pay attention when you're creating scroll-based animations in Blender, and it's about interpolation between keyframes. If we go here on key interpolation mode, by default, it's probably apply Bezier curve or one of these options here. But if we keep the interpolation between keyframes this way, when we import this into React 3 Fiber and ThreeJS, and then we run this with code, the sync between the keyframes and the sections that we calculated, it will all be messed up. It won't work the way we are envisioning this. So the secret to make this work properly is making sure that we select all our keyframes by tapping B, selecting everything, into key interpolation mode, and we apply linear as the interpolation between these keyframes. So it's just like in Webflow when we create a new interaction, and like between the keyframes that we include there, we have linear by default. So we need to make sure that the default linear interpolation is applied here, because we want the code to actually take care, be responsible by the easing between these keyframes, because when we want to make sure that everything will be properly synced. So what will take care of the interpolation between these keyframes and the timing, the easing, will actually be the GSAP scroll trigger with lens. So that's how we will control the easing between everything. Okay, so this is very important. That's all we have to do on Blender. So once we are satisfied with our scene, we're ready to export. Then it's time to export to GLTF. So let's select everything with A. So everything that's visible on the scene will be selected. So make sure to select everything that you need. So we'll go to File, Export, and GLTF. So this is the file view, and we have a few options here. First one is the file format. You can export to GLTF separated. This will generate multiple files. I don't recommend this one. You can embed everything inside one GLTF file, and you can just create the GLTF binary, which is the GLB. And this is probably the best file format because the file size at the end will be smaller. Okay, so I just selected GLB, and then inside include, make sure that I have selected objects, cameras, and punctual lights. So everything that is here, including the lights, will be exported with GLTF. Inside transform, just make sure that this is selected. Inside geometry, it's important because we want to apply all the modifiers. So we make sure that whatever we see here on Blender will also be replicated there. So the geometry will follow the modifier version of the meshes. Okay, UVs must be exported as well, so that will make sure that the textures are working on ThreeJS, normals, etc. The rest is like kind of automatically selected for you, so don't have to worry about any of these things. Compression, I haven't explored this option yet, but I'm assuming that this will affect the file size significantly. Then animation, this is important. Don't select this, and inside animations, make sure that group by NLL, non-linear animation track, is deselected. Well, it depends on the usage you have. Like if you have multiple animations, then you want to control them individually. Yes, you might want this because this will generate several animations inside an array you can use on ThreeJS. But for a use case here, since it's just one thing that's being animated and want to export, and we wouldn't want to break this down, we just want to keep it simple. It's just one animation. Then you make sure that you have this group by NL nonlinear animation track deselected, okay? And the rest of that stuff, you can just leave it as it is. And then export GLTF. And yes, that's it. That's all you have to do in Blender. Next, time to transform the GLTF file into something that we can use inside React FreeFiber. So we're going to use a tool called GLTF JSX. This is not actually a tool. It's like it's a node package, but we have a website that we can use to run this for us. We can just drag and drop the file. So we drag and drop the file inside this website that will convert the GLTF file into a React FreeFiber component for us. So we can just grab the component code and then just paste into CodeSandbox, and that's it. And the way it generates the component for us, the JSX component, is in a way that we can like have multiple objects coming from our GLTF file. But if you want to exclude or remove or point to specific elements inside the file, it's very easy. So I'm going to see that in a minute. This is the website. I'm going to add the link on the video description, okay? And all we have to do, come here. So this is my file. Just drag and drop. And that's it. That's all. It's done. It's done for you. You can even see your model right here. And yes, the shadows are weird, but don't worry about this because we're going to tweak all of these things later inside CodeSandbox with React FreeFiber and etc. What really matters here is what you have right here. So you can see that it's importing some libraries from React. It's importing a library called Dre. Dre is very, very helpful. It's a collection of abstractions that you can just use inside React FreeFiber. It's very useful. And then you can see here that it's exporting a function called model. And that function is responsible for loading your GLTF file, including inside ThreeJS and React FreeFiber. So you can see here that all of this code, it kind of looks familiar, isn't it? Because it looks like HTML tags. And that's how, that's the beauty of React FreeFiber. The way you create components, like it's flexible, you can do whatever you want, but you can use a familiar code syntax to generate the objects on the scene for you. And that's exactly what this tool is doing. It's taking all of the objects you have on your GLTF file or GLB, right? And then turning them into all of these tags. And they have references, they have the names, so that's why it's important to name your objects in Blender, because now you can see what is what, right? You can know that this is the camera, this is the base, this is the bottom metal, rubber, the dial, and all the other keycaps. And then you can pretty much just copy all of this and then paste on CodeSandbox. I'm going to show this in a second. But that's all you have to do here. This was very helpful because it cuts a lot of development time, because otherwise you would have to create all of this code here from scratch. But you don't have to. Just use this tool and make your life easier. Okay? The next step, CodeSandbox. So CodeSandbox, like I said, it's a browser-based code environment, and it's very flexible, can do a lot of stuff with it. And the beauty of this is that they have a new feature called CloudSandbox. So the same way you run Node.js on your computer to run some scripts, like you're developing locally and you want have all these modules, JavaScript modules connected together. You want to generate a static file to be included on a static website later. You do that locally with Node.js, or you run scripts on a cloud service. That's exactly what you can do with CodeSandbox Cloud right now. So that's exactly what we're going to do. We're going to use the cloud version to generate the static assets that we're going to include into Webflow. And plus, you can have like a real-time review of the things you're doing, which is perfect. So yeah, this is CodeSandbox. Like I said, you can just click here and create a sandbox. And this is the thing I'm talking about, the cloud sandboxes. It's like running a micro virtual machine on CodeSandbox. That's why you can run Node.js scripts there and have files generated for you. So I created this CodeSandbox, which is like a template. You can just open this link. I'm going to add this on a video description. And just click on fork, and you have your own version of this. I'm calling this the Flowboard plus React Fiber template. And this is the template I'm going to use moving forward for any of the 3D stuff I do for Webflow. And there's a few goodies here that comes with the sandbox template. You don't have to configure anything. It's all kind of ready for you, okay? And so here we have a system that uses React and React Fiber. These are two libraries that are already installed for you out of the box. And it's also using Vite. So this is like a version of the React Fiber plus Vite started. It's another template. So I customized, and you can use this or this starter template, whatever you want, right? And Vite is it's kind of a package bundler. So you run a script. As you can see here, we have a few scripts that we can run. If you run the build script, this will generate for you a static file. That's what we want after we finish building your whole composition here on CodeSandbox, and we're satisfied with it. And the way you do that, like you have this plus icon. All you have to do is click here and click on build. This will run the build process for you and will generate a static file. So let's close this. Okay, so it's including React Fiber. It's using Vite to generate the static file for you. What else we have here? We have Dre, which is the helpers for React Fiber, like I said. ThreeJS, obviously. Well, this is not included. It's just a resource I included here. But we're also included GSAP, because I'm using GSAP to animate GSAP and scroll trigger to animate the whole scene. So playing your animation that comes from Blender as you scroll. We're also using GSAP for other things like text-based animations, and also the interaction when you click on the keycaps. What else? We have Lenny's. Obviously, it's one of my favorite libraries to add this move scrolling behavior that we see right here. Oh, there's a few other helpers like split type to like split all the words into lines. Oh, sorry, all the text into lines and words and characters. That's something used along with GSAP. Yes, we also have post-processing. Post-processing is another library that you can use with ThreeJS to add some effects on your render. And that's what we're using to create this bloom effect for this neon light effect. It's using post-processing. I'm going to show the details in a minute. So that's the introduction of this the sandbox. You can pretty much just go to this URL and fork and modify the way you want it. All right, so let's jump into the file structure. All right, so let's start with the HTML file. So the structure here that I created is very simple. I'm basically just importing some Google fonts here to make it look a little bit better. This is the most important element, the root element. Then we have the page wrapper that contains all of these sections. You can see that each section is inside a square with these borders, right? And as I scroll, I see the text animating, etc. So all the text is right here. The text have some data attributes here. That is something that you can reuse in Webflow. That's the purpose of doing this. Then we have some inline styles just to format the HTML a little bit. And here at the end, we have our index file. This is not the file you're going to include in Webflow. but it's the file you import here that contains and groups together all the code you're going to use on Webflow later. Okay, so the most important part here is obviously our root element, and the root element right now is just one div, which is using position fixed, so it's fixed on the screen. It takes the whole screen, and that's it. That's all you have to do with CSS. You were going to do the same on Webflow later, but here it's nice because you can have all this preview. You can see in real time what are what the code changes are doing with the scene itself, right? And you can see here that I'm not including with code inside. I'm not using modular code to include the URL for the GLTF or GLB file. And the reason for doing this is because if you do that with CodeSandbox, it's like it's using relative folder structure. It's not going to work with Webflow when you import a static file. It just won't work. So if you're going to reference an external file like a GLB or GLTF on ThreeJS, but you're going to embed that in Webflow, you need to use absolute URLs, just like we have right here. So URL that we have right here is the same URL that it's generated right here. If I click here, you can see is the same. So this is the base URL for our sandbox. If I open this on a new browser, you can see it's the same thing. So I'm using that base, and then I'm pointing to the GLB file, and I'm using data attribute called data model. Okay, and you can see here that the folder structure is simple. We have our source, that's where all of our JavaScript files are included. And here on public, I have my GLB file. So it's called public, but when you generate the bundle version, this is like anything that you include in the public folder on CodeSandbox will be on the root of the domain right here, right? So you don't have to include public on the URL. Now the index file. This is where we start diving into the JavaScript code. So we're importing a few things here. We're importing React. We're importing the create root function. We're importing Dre for use GLTF. We're importing GSAP, scroll trigger, split type. All these libraries comes with the sandbox. We're also importing Lenny's because you can do that directly in Webflow, but if we have a CodeSandbox to contain all of our code, I'm just doing everything related to JavaScript inside CodeSandbox anyways. And we're importing another component called app. That's where we start our canvas for the 3D scene, right? I'm also importing here another component called events. This is like a custom thing that I created just to make it easier to point to connect things between the code here and code inside React and ThreeJS and whatever with Webflow. It's very simple. I'm going to show later. So okay, we have all of this. Then the usual stuff, which is that we register the scroll trigger plugin. Then here we are instantiating the root element, right? And we're using data attribute to grab the URL, the source of the model. So if we have the model, then we create the main canvas. We include the app inside the canvas. So we render the app inside the main element on React. This is React stuff. Then we preload our model, right? And notice that we have a model property inside app. This is how React works. This is how you pass properties between parent and children components, right? And we're passing here the absolute URL of the GLB file. I'm going to show how we're using that later. Okay. And then the rest of the stuff here that we have, it's like basically just initializing Lenny's. For Lenny's stuff, you can see my other tutorial. I'm going to add a link to this later on the description. So this is all mostly Lenny's stuff. We have a specific line here with request animation frame. This is coming from Lenny's, but there's one line here that's very important, which is this scroll trigger update. Basically, what we're doing here is making sure that the scroll behavior between the scroll trigger on GSAP and Lenny's, they're all synced together. So that's why you need to include this line here inside this function. Okay. Then this is coming from my another tutorial. It's a way to on Webflow, if you have anchor links, that's how you add anchor links without breaking anything. So this is also explained in my other video. And then we have some GSAP code here. But this is GSAP code is based on Timothy Rick's cloneable, which is very simple. It's for animating text. So it's just reusing that. I'll add the link to that cloneable as well on the description. So that's basically what I'm doing. I'm just creating a scroll trigger instances for any of the elements that contain text split. Then we use the second data attribute to figure out which type of effect we want for each one of these instances of scroll trigger. That's all we're doing here, right here. We have two letters random and lines fade. Okay, that's all we have inside our index file. Then the important part comes here on the app file. So let's open the app file. And here is where we start using React 3 Fiber. So our main React component here, so everything React is like a function, and exporting a function, add the name of the function, that's the name of the tag you use with JSX. Then whatever you return inside this function is what it's going to be rendered on the root element. Okay, so here you can see that we are grabbing the canvas element, which is just an HTML canvas from React 3 Fiber. We're also importing a few things coming from Dre, soft shadows, and environment. We are importing our model right here. And we are also importing the post-processing components, the bloom and the effect composer. These are the things that will create this neon effect here on this material, right? And then all we're doing is make sure that you're passing the props down. So we have our canvas, we're making sure that we have shadows enabled. The DPR is 1, so make sure that the performance is okay between desktop and mobile. The higher you use your DPR, the better the quality, but slower it will be. Here is just a few other things that I learned from Anderson Mancini to make sure that the performance will be good for mobile as well. We're disabling anti-alias. Like I don't know the full details about all of these things, but I tested, and yeah, it makes a difference when rendering all of this in mobile. So inside Canvas, we have a few things. We have our soft shadows. I increased the samples to make sure that it won't look weird compared to what we see here, right? All these jagged lines here. It's because the samples are small. I increased the samples right here. This suspense element coming from React is an element that will make sure that nothing will be displayed until anything that is inside the suspense element is properly loaded. We're using this because we have to load the GLTF or GLB file. That might take a few seconds. So we're using suspense to make sure that nothing breaks while we're loading it. And then we have model. That's where the magic happens. I'm going to show in a minute. And we're passing all the props coming right here. So make sure that the absolute URL of our GLB file is coming all the way from the index file down to app and down to model component. Okay, then we have effect composer. That's how you use post-processing library, and then you add some layers of post-processing effects. And I'm using here 3 layers of bloom effects to make this nice bloom effect for the neon light, right? So 3 layers right here. I'll add the links for the post-processing library on the description for the video so you can understand how this library works. And then environment is just basically it's just an environment. It's like a HDRI texture that makes all the reflections and lights on your scene feel a little bit more realistic. So we're using a preset called Sunset, which adds this nice little warm light surrounding our keycaps and everything else. And that's it. That's our app file. Now the model. So this is where the whole thing, the magic happens, and there's a lot of stuff happening here. First, we're including a few things from the React library. Use ref because anything that you want to move or change must have a reference. So we're using use ref, use effect. I'm going to show later why, and use layout effect. I'm using use layout effect because GSAP has documentation. Actually, I forgot to show that. So GSAP React. When you're using GSAP and React together, they have a nice article here explaining what are the best practices to use GSAP. So we're using all the hooks and this snippet of code here to basically generate our GSAP code inside our model component. Okay, so that's coming from React directly. We don't need this. Then from Dre, we're importing use GLTF. It's just like a abstraction layer to load our GLB file. Perspective camera and use animation. This is all coming from this converter for us. So you can see that it's that line specifically. Okay. Then we're importing GSAP, obviously. We're importing ThreeJS because we're going to use something from ThreeJS later. Use loader from React Fiber to load a texture. It's just to make the metal reflection more realistic. The RGB loader, it's also something that you need to use here to load the texture, the HDRI texture. Scroll trigger, we're registering again, and that's it. That's all we have here as libraries that we need to import into our model. And then everything inside here, it's basically a modified version of what we have right here. So if we start scrolling, we have a few references here. We're loading our GLTF file right here. Okay, that file. And we're using the absolute URL that came all the way from index into this model. So it's all coming from props. We're grabbing a few things from the GLB file, the animations, materials, and nodes. I think this is also coming from here. So all this, it's boilerplate code generated by this tool right here. We're grabbing the animations using another hook called use animations. Again, we're generating the texture here that are going to be applied to one of our materials. Then we have here a few other, we have a code here to generate references for all the key caps. I just created like an array of keys and I'm programmatically generating all the references. This is where we start using the recommended setup from GSAP. So use the layout effect. We have our animation. We're grabbing animation duration here. We're grabbing the clip. So remember that when we were on Blender, we made sure to not export animations individually. So that's how we load our animation clip. Because on ThreeJS, every animation is like it's like a clip and has a duration. So we have these two lines to make sure that once we hit the bottom of the screen, this won't start a new loop on the animation. So that's why we have these two lines. Then we have the play. We start playing the clip, but we're actually not playing it because we're using GSAP to move the progress of this animation. We're going to see that in a minute. And we have the mixer coming from ThreeJS right here, instantiated, and that's it. So starting with the GSAP code. So inside GSAP context, have a proxy object that has a property called time, and it's a proxy because we want to get a specific file when we get time. And we also want to run a specific logic when we set the value all the time, when we update the value all the time with GSAP, right? So you can see here that we started playing the scene here, but inside the setter of time property, we pause. It's already paused later, but we remove the pause. We set the right time to the right place, the right value. So if it's like if your animation has 30 frames per second and your whole animation with 150 keyframes will contain 5 seconds, right? So if you're on the second section right here, it's not running right here, but it just needs to refresh. So if when you start going to the second section, the keyframe, the starting keyframe here is the keyframe 30, which is like 1 second. The second, the value of the right time on the timeline will come from GSAP. And we need to set that time on the whole timeline coming from the GLB file format. So that's what we're doing here. We're removing the pause of the clip. We're setting the right time. We're pausing again. That's how we set the right frame on the whole animation coming from Blender. Then we set the initial time to 0. Make sure that it's not like running anything weird. We start our timeline for our scroll trigger. So the main trigger is the page wrapper element. So grabbing all the height of the page wrapper. We're not painting it here. We're just using CSS to make the element that we want fixed on the screen. So basic scroll trigger stuff. The animation starts from the top of the page and ends at the bottom of the page. And then we're using the from to make sure that the proxy time value starts at 0 and animates from 0 to the animation duration. That's the value we grab right here. Right? So if it's 5 seconds, we're making sure that it runs from 0 to 5, from top to bottom of the page. Right? We're making sure that we set ease, the ease function is none, because we don't want to have an extra easing function. We just want Lenny's to control the easing function while you scroll. So everything will be controlled by Lenny's. And that's it. That's the whole code to update or clip and the progress of the clip and make the animation run. I think this is not working. Let me just refresh here. Okay, just refresh it, and yes, so as you can see, all this logic running the animation that came from Blender is controlled by this timeline. That's all. What else? So another animation we have here, we have the material of the base of the keyboard. It's kind of rotating between like a light blue and a light purple or pink color. Right? This is also controlled by GSAP. We have a timeline here that is repeating infinitely without any easing effect. We have the yo-yo property as true, so it's moving like from 0 to 1 and from 1 to 0 back again. So it's not like a loop. It's like going back and forth multiple times infinitely. And then we have something here which is the base neon material. So if we scroll back here, we see here that we have a reference for the material called base neon. So this base neon current material has a color. So we're starting the color right like this. So we're splitting the RGB channels for that color. So it's not like hexadecimal just like CSS. It's RGB, and it's not just RGB from 0 to 255. Usual way to reference RGBs. It's from 0 to 1. It's like a person. It's like 0% of red or 100% of red. So that's how we're setting up things here. So RGB like this, and the duration of this light blue animation is 1 second. Then we are also again animating the same property, the color, with different values for RGB, again in 1 second. So we're tweening between these two colors. And yes, it's tricky to calculate these numbers, and there was a lot of trial and error between these numbers to make sure that we have the right numbers for the right colors that we wanted. So to make our life easier, there's this website that I use to kind of calculate the numbers. convertingcolors.com is very, very useful, and you can use this to calculate generate percent version of RGB based on an hexadecimal color. So for example, I included here red, right? This is the hex code for red. Click it convert, and then it will show you multiple formats, and one of them is RGB percent. And you can see that it's 100% red, 0% green and 0% blue. So 100% is 1 and 0% is 0. So these are the numbers you need to use here. But the neon effect is using post-processing. And the way post-processing is working right now, going back to the app, there's something called luminance threshold, which means that it's a trick that we use to select the specific objects that we want to have this blooming effect. And you can see that only the base it's actually having this, not the keycaps or anything else, just the base of the keyboard. And the trick is we use luminance threshold to say that anything that has a value above 1 on the colors will have this effect. Anything that has the color like lower than that won't have this effect. So that's why we have some weird numbers here. For example, for blue, it's like it's not 1, it's 11. So if you increase like more than 1, then that object that has that material will have this bloom effect applied. But I had to play with the colors here, the values, to make sure that it's working. So it's not like there's not a formula for that. It's more like trial and error. But I got these values. What else? We're using use effect here because I want that once the model is loaded, the GLB file is loaded, Webflow, I'm going to have a loading animation. I want that loading animation to disappear once the model is properly loaded. So I'm using this React hook to make sure that I'm triggering a specific custom event, dispatching a custom event on the root of the document with this name and with this label. That's how we're connecting things together. I'm gonna show that later. And yeah, that's it. And then we have another piece of functionality, the clicks on the keycaps, right? And we're just doing this by grabbing the ID of the key cap and using GSAP to animate. Well, for the dial it's just rotation, and for these elements are positional. This is the only animation that we're not generating on Blender. We're just generating here on with code. Okay, so it's just translating the eye position. So the object with the reference coming from this ID has a current position, and on that position we're translating the y-axis with a duration of 0.1 seconds. So that's how it works right here. So we have two functions like that, the animation click in and animation click out, and that's all. Then we see all the elements coming from the GLB and this converter that we have used here, right? And we're modifying a few things. You will see that, for example, the lights are not actually lights, they're groups, because I think this well, it doesn't convert the lights. But since these groups are using the same positions and etc., so they're all in the right places, I just turned the groups into a directional light. This is coming from React Free Fiber. Then I just added like a few things like the intensity of the light, the property to cast shadow, the map size to make sure that the shadow is smooth. So I play with the properties here, the color of the light, just to make sure that lights are working as expected, right? Then we have our camera. And our camera, on React Free Fiber and React and ThreeJS, if you don't set a default camera, then it will do that for you. It will generate a default camera. That's one of the abstractions that comes with React Free Fiber. But we do have a camera, right? This perspective camera that came from the GLB format. So we're using make default equals true to make sure that the camera the right camera is being used. Then we have the base neon, which is the base of the keyboard. And it came with a standard material coming from Blender, but we're not using that material. We're using our own material called basic material. Right? And you see that the reference here for this object, this mesh, is using that same thing. So it means that we're using the basic material, but we can have access to this basic material with the code right here through the current material object. And you can grab the color, right? And another thing to make this neon effect work is make sure that tone map is turned off. So that's it. And here's the bottom metal thing that I'm using a texture to add some more realistic lighting effects. So this is the metal part, bottom metal, and you see here that we have an env map, the environment map, pointing to that texture. Okay, so that's why we have loaded that texture. And we have the rubber, and finally we have our keycaps and the dial. And you can see here that all of them are receiving their specific ref, casting shadow, receiving shadow. And then we have here two event triggers, one pointer down and one pointer up, right? And when we click here, make sure to stop propagation, otherwise it will behave weird. Then we trigger that animation, that function that animates the click. It's click in, and once the pointer is up or you're not clicking anymore, then we animate with click out. And all of the keycaps, they have that. So this was added with custom code. And that's it. That's all the logic in the model. So we're using basically GSAP and scroll trigger to animate the scroll behavior. We're using GSAP to cycle through the colors on the new file, the new material. And we're using GSAP to animate the clicks, make it interactive. Okay, that's it. And then this piece here, like I said, it's a custom event I'm triggering. And I've also created an events module, very simple. We're basically just grabbing here all we're listing to all events on the document that has a specific name, custom name. It's a custom event. Once we identify an event trigger from that, we grab the details of that event, like that, the label, the format of this label is saying, we're splitting that into two pieces, the type of the event and the trigger. And then we're using code to, on Webflow, if we have an element with a data attribute with this specific structure here, then we trigger whatever event we want. So here we're saying, I want to trigger a click event on Webflow on an element with this specific ID. So if the specific element has a data attribute like this and also this, so this is the data attribute you need, then I'm going to click on the element. That's a trick I use to programmatically trigger interactions on Webflow. And that's it. That's all you need. Once you have all this code generated, like this is how I built this, but you can do whatever you want. But now you understand the process of creating the HTML file, so you can see in real time all the changes you're doing, the index file containing all the extra logic, the app file that starts using React and React Free Fiber, some of the properties we use here for performance, for extra post-processing effects, from extra lighting stuff, and then our model that contains the GLB objects, the whole scene coming from Blender, and all the logic to add the interactions with scroll-based interactions, clicking animations, and etc. That's the whole thing here on CodeSandbox. And once you're ready, all I had to do is click here and run build. So it's running the Node.js script for you, and that's it. So you can see here that there's two folders, right? And you can't actually click and copy here because this is like it's a virtual preview of command line running inside this virtual machine. So I haven't found a way to copy this, so I'm basically just copying the URL here, index, the name of the file, cd22f8.4.js. That's all you need. All right, and that's all you have to do on CodeSandbox. Yeah, it was long, I know, but it's important to understand all the basics here. Next step, finally, Webflow. So Webflow, basically, we just import a script. We create the root element that will contain our 3D scene. We add all the UI elements. We build the whole structure. We add interactions, and that's it. So that's the end of the whole process. So here on Webflow, this is my project, and pretty simple. We can see all the structure here, the header, the sticky container with the root element, all the sections that we have right here, and the footer, right? Have a HTML embed here, just like for responsiveness in general, so making everything scale properly. And here we have our loading wrapper. And then we have a hidden element called loading close. If you remember properly, here we triggered that click event on an element we did we call loader close. This is the element. If you go to the properties, you see that we have here the data attribute that we are looking for with the code here on CodeSandbox, right? And when you click here, we'll trigger loader close animation, right? And that's basically it for the loading animation. And then root element, which is the most important one. Basically, we're just recreating the whole thing here that came from CodeSandbox. It's just a div with position fixed, taking the full screen, and the layers are controlled by the Z index, right? And the important part here is the data attributes. So remember that on the HTML, have your data model attribute pointing to this URL for the GLB file. We're doing the same thing right here. For a data attribute called data model and the source of the GLB file right here. So that's it. And then finally, if we go to page settings, we don't have any extra JavaScript logic here because all the logic for JavaScript, for GSAP, scroll trigger, lennies, text effects, all of that is all contained into CodeSandbox. So why include code here if we have everything there? So all I did was to copy the URL of the static file that was generated for the JavaScript file into space here with the domain, dist, assets, and then the name of the file. I have to update here. Click save and publish. And that's all. That's all you need to have something like this. Cool, right? And that's all. I know it was a long video. I hope it was useful somehow. I hope you learn a few things here. I know it's a lot of advanced stuff, especially learning like CodeSandbox and React and React Fiber and all that stuff. But I think this process, it's an easier process compared like to just trying to do ThreeJS, vanilla ThreeJS, and building a whole scene there. And like React Fiber makes your life easier. There's a lot of libraries that makes things a lot easier compared to vanilla ThreeJS. You don't have to know a lot about React to use this. You can just clone this sandbox and reuse it. And this whole process makes things easier between Webflow and ThreeJS because the way you include a scene, it's easier, and you can have connections between Webflow events and Webflow interactions and events inside ThreeJS, just like I showed you. So yeah, that's all. I hope this was useful. Make sure to subscribe to the channel and turn on notifications because I'll probably have more tutorials around ThreeJS and Webflow in the future. And by the way, just let me know, what do you want to learn about using 3D and Webflow together? Just let me know in the comments and I might pick a few ideas for future tutorials. That's all. Thanks.